Uh, all right, I am here. Let me get attendance real quick. I've got the recording already underway. And obviously, Collaborate has made some changes. As it shows for me, whether your microphone is enabled or disabled now, looking more like on GoToMeeting and some of the others. So a little bit different on that. Hopefully y'all can all hear me at this point and see me.
Yes, sir.
Okay. So we'll go from here. And this is going to take a little bit of time today. But I'll go as quickly as I can over on it. But this week, next week will be the last one that will be graded. Because we're actually down to the last couple of weeks. We've only got 3 weeks left, I believe, counting this week in the semester, if I'm remembering correctly. Yeah. This week, next week, the following week, and then the 3rd is the last day of class for the semester, and the 4th is final exam day. And the 6th is actually graduation evening. So this week we've got a Collaborate session that's being graded. Next week we'll have a session also, and then that will be the final session. Because following week class is over when we get to Tuesday. So we're down to the end. However, next week will be the last one I am going to grade. The following week on the 27th, there is not a discussion that week. That's the last full week of class, and I'm not doing a discussion that week because that would be due on the 3rd, and that's additional work on me grading, and it's supposed to be an interactivity between me and the students, and it would be, by the time I get it graded, obviously would not grade it on the 3rd, and after the 3rd, the semester is technically over other than finals. So I don't do one that last week. Besides that, it cuts my workload down in when the semester is ending, because your class ends the 3rd. Finals are due on the 4th, and I say on the 6th that evening we have graduation in Rome, and I have signed up to go down there to it. Somebody I told I would go there to the spring graduation. I don't remember who it is right off the bat, but I know I did, so I went ahead and signed up for it the other day. I'm only required to attend one graduation a year, and I did go to the Dalton one in the fall, but I'm going to this one also. It will be a drive-through graduation, just like Dalton and Rome was last August. However, I did not go to the one in August. And so I'll be attending that day. Grades are usually due that Friday or on that Monday, and I think they are due that Monday, but I really would like to get them in by 10 o'clock that Friday morning, which is a lot of times the deadline, and maybe the deadline, because I really haven't seen the deadline, but I think I saw something that said it would be that Monday. But that next week is a chance for me to take time off, because normally we're supposed to do our annual leave taken when classes are not in session. So that means that next week. Actually, that Friday, that Thursday, that Friday, that week are days also, but I'll definitely be grading stuff on that Wednesday, and that Thursday I'll definitely still be grading and got graduation to do. So This week you do have 2 modules, but then you've only got 1 module a week after that, because you got module 16 next week and module 17 the following week. It's just when you got 17 modules and 16 weeks, I think we had this semester. Somewhere we had to do 2 modules.
Okay.
So this was where I happened to stick in 2 modules, was for this week. So it's just how it worked on how I did on the calendar. So 14 and 15 are due this coming Monday, correct?
Got it.
So that's where we stand on status-wise on all of that. Welcome Back Week, or they're calling it Spring Fling this time, but it's been called Welcome Back Week a lot of times in the past, Spring Fling sometimes too. But theoretically, our Welcome Back Week, which for spring semester, we never do have it. Actually, either semester in the first week, although they always called it Welcome Back Week. Fall and summer usually falls a week or 2 after the semester starts, because the first week is chaos anyway, so it doesn't make sense to be trying to do stuff that week. And actually for Spring Fling, it is going through, it's the last activity in it for the last campus will be on that Tuesday of that last week. So the 27th is when Catoosa has their Spring Fling Welcome Back Week activity, their spring activity. Walker had theirs Monday a week ago. Unfortunately, I didn't make it to it that day, so I had some other things. The next semester starts on the 17th, if I've got my days correct on that. Let me look at the calendar real quick to double check. Went to March instead of May. And yeah, the 17th should be the first day of class for summer. Now, that's another issue in there too, is besides being able to take off time then, I also have to have classes prepared and ready to go on the 17th. So that sort of limits me on what I can do during that time period too. And I'd really like to get a little bit of time off. I do have a little bit of some travel to a couple of events, 1 or 2 events in the summer planned. One that I'm having to wait until the end of this week to find out if it is occurring or not, because National BB Gun Match that I work with every summer in Arkansas, they're going to make a decision by Friday or on Friday of whether they're going to have the event this summer or not. The next question for me still will be, will I be invited to go to it, which I suspect I will be, and that happens around the 4th of July weekend. They're having to figure out whether it's feasible to do it and to meet CDC and Arkansas guidelines at that point and everything, and make a decision on how safe it would be. It is a crowd there every time. I have a feeling, and I told them that when they said on it, I said, I have a feeling you're going to cancel it again for this year, although that's regrettable on it, but I don't think we're going to have much choice on it at this point. But then I'm supposed to go to Kiwanis Convention in Salt Lake City a week or 2 before that, towards the end of June, and I'm going to drive out there and come back, and that's going to be somewhat of a break for me, but I will be, those of you that are taking class from me this summer, which could be some of y'all, no Todd will be in there, and I'm not sure who else, that are taking 2452 or something else from me. I will be online every day and still doing stuff the whole time I'm gone on that. So I'll still be working too, so it won't be where I get away totally for a few days or whatever. Okay, now chapter 14 looks at the transport layer. Chapter 15 looks at the application layer. And when we're looking at that on the application layer there in 15, that's looking at application layer in terms of application of the TCP/IP model. So it's including the top 3 layers, including application layer of the OSI model. And that's normal. Those layers are usually lightly covered. So we're going to talk about those 3 real briefly there. The transport layer is the layer. One of the key terms on this layer is flow control. It's controlling the flow of data between your devices as you're working with it. So you're going to basically use 2 protocols on the TCP/IP. On the transport layer, I guess it is TCP/IP transport layer, but the transport layer, and remember the transport layer is a transport layer no matter which model we're looking at. That's one of the easy ones in terms of that. But you're using 2 protocols on it essentially. Now there's some other protocols work on it. Novell, when it used to be around, had its own protocol on this layer, which right at the moment I can't remember what it was. It ended in X. SPX was the one for IPX. Okay, it's SPX. I just told you what it was. SPX was Novell's transport layer protocol. But that one you really don't see. IPX, which I mentioned previously in the previous chapters, yeah, I still see that one appear sometimes in a reference on it, although it's really not used anymore. The X gives it away that it's a Novell one. But so essentially all you need to know about is TCP and IP, and TCP and UDP. Sorry about that. TCP is going to be reliable. It's connection oriented, and those are key terms you need to know. UDP is not reliable, and it's not connection. It's connectionless, to use the correct term there. So you need to be aware of those terms. With UDP, actually and now on this layer, we're working with segments. So we've talked about packets, we've talked about frames before for our protocol data units or packet data units, PDUs. You'll actually see the P and PDU be protocol or packet. Tends to be more protocol nowadays than packet on there because that's confusing with packets. But it could be. So segments is what we're working with on this layer, on the transport layer. With segments, we're breaking the data when we're going downward. We're breaking the data up into usable pieces, and we're putting a segment number on each. And then when it rises to the other end, it can put it back together using those segment numbers when it's coming back up, and you get the whole chunk of data again. So what you're doing right there is you've got this large chunk of data to send. Let me jot down. When I see somebody coming in, I try to jot it down immediately so I don't miss it. Also, grading. I've actually graded what was due yesterday has already been graded. I just graded it about an hour ago, within the last hour. So we're in good shape on that. But with the UDP, what it's sending across is really basically simple on what you're seeing there. Remember, the segment's going to be encapsulated in the packet in the frame as you go downward. So at this layer, you've got a segment. And as far as UDP is concerned, basically all you've got for the header is a really simple header. It has just simply got the about 3 items of information, and I'm trying to think, and they combine stuff together real rapidly in this chapter. So I'll put pages to catch exactly the page they do it on. I guess I'd gotten ahead on where I said that. So the header on UDP has the source port, and I'll talk about ports just a second, the destination port, and what the length of the header is, and a checksum figure on it. And then the rest of the UDP on there has got the data in it along with the segment number. Okay? So it's a really simple piece right there. So that's a simple PDU. Now, the TCP one has got a lot more stuff put into it. So it's got source and destination port. Talk about those a second. It's got a sequence number, which is, we'll talk about as we see how TCP actually works, but that's the order of these segments as they go across, okay, as it sends them. And an acknowledgement number, I'll talk about that one too. And the length of the header and the window size, and we'll talk about that in a second. And the checksum you're already aware of. So notice TCP's got a lot more to it. Now, having mentioned, before I go into talking about, so UDP, all UDP does is it sends the information and waits for no acknowledgements. It doesn't know it got there. TCP sends information, makes sure it arrived, and sends it. And so it sends it in groups smaller, or sometimes it sends it all at once, depending on the size of it. But where you're going to picture it normally is it's broken up, and so it's sending parts of it along and make sure each part gets there. It makes sure it all gets there. So it assures everything gets there. UDP does not. As a good comparison for you is, think about UDP like a radio or a TV station, and think about TCP like a phone call. With a radio or TV station, they broadcast and they trust there's people out there actually listening to them. So the announcers on a TV or a radio station are sitting there talking, and they assume they're talking to people out there, but they really don't know if they are or not. Okay, now there's some ways that we do some measuring of ratings, etc., but they don't know for sure anything they say or anything they put on there gets to anybody. Okay, so that's like UDP. TCP is like a phone call, and we're going to come back and mention it again in an example in just a second of how you actually connect on it. With a phone call, you know the other person actually hears you. Actually, when I'm doing this collaborate session, to a degree, it's sort of like UDP, but yeah, it's got some of the TCP because I do get a response from you, but I don't, that there's nothing guaranteeing me that it gets to someplace. But with the phone call, you make a phone call, you talk to the other person, you know that they actually heard what you told them, okay? Because you do confirmations back and forth, and so there's a confirmation of what's been said. So you know it's been delivered, the message you want to deliver. But if you did it across the radio, you don't know if anybody actually heard it or not. And that's going to be UDP for the radio TV. Phone call is going to be like TCP. Any questions on that general part right there? Now, let's look at, so UDP, it just starts that you go to send something with UDP, you just send it and trust the other ends there. So that's simple. TCP is what they spend most of the chapter on, and then we'll talk about ports briefly. TCP, to initially establish the conversation, you're going to have two machines. Now let me see, I'm going to try to do a whiteboard on here. I wished I'd gotten set up my pad that they just bought for me earlier. That's supposed to let me draw on, but I'm going to share a whiteboard, and then I'm going to draw here for y'all. So I don't think it lets me choose colors. So we've got a machine 1 and we've got a machine 2. Now these can be, they can both be servers, they can both be PCs. One of them can be a PC, one can be a server. Doesn't care which one. It's just we've got machine 1 and machine 2. To establish the conversation, machine 1 will send a sync signal to machine 2. That is just like on a telephone call where you pick up the phone and you call the other one. Nothing's happened yet on it. Now, machine 2, when they get it, machine 2 will send back an acknowledgement. So that's the phone stops ringing, so you know somebody has answered it after all. So there's an acknowledgement that it came in, and it will send back a sync signal, which is sort of like that they just answered hello. So this was step 1. This is step 2 of the 3-way handshake. Okay. Now, this also has a number on it. Quite often in their examples, they'll use 100 for it, but it's a random generated number for the sync signal that 1 sent across. When 2 responds to that sync signal, it responds with a number that's 1 bigger than what the sync signal was. And that way the 2 know what they're talking back and forth, that these messages match. And it will generate a number on its sync number that's also a randomly generated number, but the book examples almost always use like 100 and 200 on these. So I'm just going to stay sort of like that. Now, machine 1 has gotten that. So 2 has said hello, and machine 1 knows that it did get the call, did get through to the other. So machine 1, this is on layer on the third part of this, it will send an acknowledgement back of 201 saying that it's received the hello from 2, and it will also send, and that will also be its hello signal that is sending back to 2. So there's been a call made, there's been a hello on it, and a hello from the other end. So now both ends are talking to each other, and that's the 3-way handshake on there. And I don't believe, yeah. And it's going to send a sync 2 because it is going to send the hello. So this one knows the hello was received, and there was a sync sent across on this. So that sync will be another number on it because it's not responding on that one. So I'm wrong. There's only a sync. Scratch that. So there's only one signal across on 3. Correction. Okay. So that's your 3-way handshake. Sync from 1 to 2. 2 acknowledges receiving the sync with a 101 and sends a 200, which is its start of the conversation also. And then 3 acknowledges receiving that sync or that hello from there and does a hello back to 2. At that point, the 1 and 2 have talked back and forth to each other, and they're now in full conversation. Y'all follow how that works right there on the 3-way handshake. 3-way handshake is important to know. You will see that pop up on test, on certification test all the time. That I get questions on it. It may be just, how does TCP establish its conversation? And 3-way handshake is one of your choices of answers. It may be the steps that are in here. Okay. But notice that step 1 was a sync from 1 to 2. Step 2 was the acknowledgement and sync from 2 to 1. And step 3, the third part, was the acknowledgement from 1 to 2. Okay? If there's not any questions, I'm going to click on erasing on that. All right, now from that point on, it then has the conversation, which we're going to look at in windowing. Then it's going to reach a finish at some point, and that's what I was going to show you now, is how to do the finish. So it doesn't keep on sending syncs and acknowledgements on this. It's actually going to send the data across. that's to synchronize and to acknowledge the synchronizing. So any other questions on this before I erase it? All right, I'm going to clear the screen. And now for the finish. So we still got to build in between what we're going to call windowing. But at the end, again, you've got a machine 1 and 2. And this can be, doesn't have to be the same. What I'm labeling as 1 here is not necessarily what was 1 in the first example, or 2's not necessarily 2 in the first example. It could be either one of them. Okay, so what we're saying is 1 and 2 is just which machine's going to do this first. It could be, doesn't have to be the one that established the conversation at the very beginning. Okay, so don't get hung up on that. So at the end, and this is really simple on it, that when machine 1 says, okay, that's all we need to do on this conversation, it's going to send a finish signal, and that's actually finish sequence, not sequence, sync, finish, sync, and acknowledgement are all codes that go in these segments that are sent across. Okay, so it's the type message on it. So it will send an FIN across the 2. 2 then has an option. It can ignore it and keep on going. Or if it's ready to finish the conversation also, it will send back an acknowledgement. And again, these are going to have numbers just like we were talking about earlier, and that they're going to, let's use a different set of numbers on this. So 300 and 301, so we know that 301, this acknowledgement is responding to that finish request. And it will send a finish request also with its number on it. And 1 will then send back an acknowledgement of 401. And at that point, they disconnect. This is just like finishing a telephone call. 1 said bye. I'm talking with Todd on the telephone, or I'm talking with Maya on the telephone. And make sure all of y'all do post things in the chat window, okay? I'm talking with one of you. I'm through with what the conversation's about, so I say bye. Now, at that point, whoever I'm talking to, Todd, Maya, Justin, whoever, has a choice. They may be through talking with me. If they are, they'll say bye back. They may not be through talking with me. They may go, I got more to tell you, Dwight. And so they've acknowledged that I said bye, but they didn't send a bye back, at which point that just dies, the finish attempt. If they say bye also, then at that point, then we've each said bye, so then it gets an acknowledged back, but we both said bye, and so we go ahead and hang up the phone. So it's working just like a phone call on it. So concluding the conversation is an easy one. A finish is sent, acknowledgement to it, a finish is sent for the other end, acknowledgement, and the session is over. I've really not seen questions on the test. I have taken certification tests, etc., that I don't remember actually ever having a question on this. This one's pretty straightforward. That 3-way handshake got a little more complicated. So be aware of this, but that there is a finishing up process, but exactly the whole detail of the process you don't have to worry as much about, although y'all can remember it anyway. So questions on that? And then I'm going to erase it if there's not any. All right. The third one is we've got this whole, whoops, let me get my pen. We've got this whole big chunk of data sitting here that we want to send out. We have broken it into segments. So there's a segment 1, 2, 3, 4, 5. I don't know what that little line was drawn there. 7, 8, 9. And what in TCP is going to happen is we're going to send groups of it at a time, which is called windowing. And it's windowing because it's just like looking out of a window. And actually, Windows' name for the program came from that same idea. You're not seeing everything happening in there, you're just seeing part of it. So in this case, what's being sent is just part of the data at any point. So that's called a window. And that's with a lowercase w. So what we're going to have happen is that it's going to send a chunk at a time. Now, your examples you usually see show sending 3 or 4 or 5 segments at a time. And I'm going to do it with 3 segments. Now, in real actuality, it may be sending hundreds or 100 or 60 larger numbers of segments across at one time. What happens to start with is, the very first thing that happens is the 2 machines will sit there and send machine 1 that's wanting to send stuff because it established a whole conversation that it needs to send something. It will initially send out and say, here's the window size I'd like to use, because it's going to use based on what it can send, how much stuff it can send, and how long it's willing to wait for a response back that has been received on the other end, which is partly based on congestion of the network, speed of the network, sizes of the segments, etc. But it's going to algorithmically do it. And we really don't have to worry about what it comes up with on that, but it comes up with a number, sends that to the other machine. The other machine responds back of either, okay, that size suits me, or suggest a different size. Normally a smaller size, because machine 1 actually probably sent across what it saw as the maximum it could do. So then they've agreed the window size is going to be 3 in our example. Okay, so what happens is it will send these first 3 segments. So it sends 1, 2, and 3 gets sent over to machine 2. So this is machine 1, this is machine 2. Okay. Now, machine 2 may receive all 3 segments. If it does, machine 2 is going to send back. So if it got 1, 2, and 3, machine 2 is going to send back the number 4 to machine 1. What it's going to send is 1 number higher than the last sequential number it received. I'll explain that a little better in just a second. But 4 is the next number after 3 because it received 1, 2, and 3. So now machine 1 got that 4. So now machine 1 will send 4, 5, and 6 to machine 2. Well, something happened this time. 4 and 6 got there, but 5 didn't get there within the time period. So what machine 2 is going to respond back with is 5, because it has received 1, 2, 3, and 4, but it hasn't received 5. Now, it did receive 6, but that's worthless to it in normal windowing. Okay? Hold on 1 second. So now machine 1 will send 5, 6, and 7 to machine 2. Y'all see how that works there? So it's keeping, now notice machine 2's got all of the segments appearing in order to it. Machine 1 knows everything that machine 2 has gotten, so it's reliable. Machine 2 has it real simple to put it all back together. Now, as they're sending this information, if a lot of segments disappear along the process, the 2 machines will stop and renegotiate a window size, a smaller window size on it. Or if by chance they're sending something really, really large and everything's getting there and nothing gets lost, they will also stop and renegotiate a larger window size. So it is, once it establishes that window size to start with, that is renegotiated as needed by both machines. And then they get it all sent through, and once they're through, then they go to the finish that we saw a moment ago. All right, do y'all see the flow control and how we've worked with this? Now, with this that I've shown you and what the book shows you is that the whole thing has to get there. However, I will tell you this, and I don't know if any of y'all are in 2601 or not. I know I do have some students in 2601 and 2451. In 2601, they introduced a new part to this about the windowing, that you can actually now do partial, and you could actually send across when 4 and 6 appeared. You could send back, it would send back 5,7, which tells it, I've got 6 in there, but I didn't get 5 and 7 yet. So it would tell it to send 5, 7, and 8 in that case. But for your class, they don't tell you anything about this partial approach on it, about sending the information. So you don't have to worry about that on there. But I'm just going to mention that to you, that in windowing now they have, and I just learned about it this semester, about that's even a possibility out there. So I'm telling you something about something that's not on the test. On the test, it is purely based on what I just told you. So this is doing your flow control within TCP. Correct. Okay. Questions for me on that, about the flow control here and how it worked. And that there, what I just did on this last screen to me. So notice in the first place, we sent 1, 2, and 3 across. That was received, so that's all there. We then sent 4, 5, and 6 across, but only 4 was acknowledged, so that one's acknowledged, and our window then changed to that, and no longer was that. Y'all follow on that? And so the next window would be 8, 9, 10 on as it works. It's just like if you're in the car looking out the side window of the car, or I look out the window here in my office. I'm only seeing part of the campus. I'm seeing the 500 building, the end of it, when I look out at it. But when I move, looking out the window, I see something different looking out the window. So it changes on what you're seeing through the window of the whole big thing that we can possibly see through the window as we go along. Or you're driving down the road and you look out the side car window, what you see right now changes as you move on down the road a little bit. And so that's why it's windowing. Questions on that? I hope that helps on it. And let's say the biggest part to it to me, oh, they do have it in here. There is selective acknowledgement. Correction, I just told you wrong. What I just mentioned at the end was about the acknowledgement. It comes back, the acknowledgement says 5 here. If you're using selective acknowledgement, which they briefly mention in the book called SACK, which would mean that sends an SACK message instead of this sends an ACK message with this method here. If you're using a machine that allows selective acknowledging, it would send back 5, 7 with an SACK. And I just noticed that it is in this book. And in that case, it would send 2 numbers on it. It would send 5 and 7 to say, start with 5 and start with 7. I got a number in between. And that's mentioned to you in section 14.6.3 on it. All right. Now, we got one more thing we got to do in this chapter, which is a big part. Next chapter is really, really light. So I'm going to brief and going over that. Port numbers. Port numbers are important for you. Okay. And I do have the PowerPoint slides out there for y'all sitting in Blackboard. And all of them for all 17 chapters are there now, because I actually got the last couple of chapters done this weekend. In my other class, I've still got one PowerPoint to finish getting ADA compliant before I can post it. That takes a good bit of time because Cisco did not make them ADA compliant. So I have to put basically an alt message on all figures in it, and then all slides have to have titles, and they didn't put slide titles on. So let's look at port numbers now. Ports tell you what protocol, technically it's what protocol is this segment associated with, which actually tells you what application is it associated with. But it's really telling you the protocol technically. So this is the way that when a machine receives this message from another machine, and I'm going to take this off the screen for y'all because we looked at that enough. And that it tells, so you've seen how it knows the address of the machine, and it figures out the addresses and puts the IP addresses and MAC addresses on there. Now on this layer, we're telling it what protocol is this message to be associated with, and who's supposed to work with it. So that gets it to the right application. So you may have wondered about that all along, getting to the right machine, but then when the machine gets it, how does it know which application does this belong with? That's the port number. Now, we've also got sockets. I will mention that to you. And the socket is the IP address combined with the port number. Now, you put the port numbers on there. I don't know. I don't have any way of knowing on that. Okay. I don't know why I disconnected, but as long as you're hearing me now, we're in good shape. So with the port number, that you can also combine the port number actually be combined with the IP address, and that's called a socket. Now, and so Justin yells at me to tell me it's loud and clear. Good, Justin. Problems, but I can't tell it on my end about it. But with it, they'll be separated by a colon. So you'll have the whole address of where you're sending it to, and then there's a colon and the port number. And the port number tells it which. Now, when you're looking at web pages and such, it doesn't normally show you the port number because it assumes it's using the HTTP protocol when you're sending it and when you're receiving it, so you don't normally see it on there, which actually uses port 80, which I'll talk about in just a second. But sometimes you'll see the colon 80 or colon 443 on the end of it. But that's how it knows it belongs to a web page. Okay. Now, you can do some playing with that, because actually I've done some playing with NAT on it, where allowing remote desktop connection, where I allowed people to log in from elsewhere to their machine from outside. I did it through NAT, through a pinhole, and used the port number to do on it. So I set, when they went to do their connection, it didn't use the default of 33. Through the pinhole and NAT, it looked at it and went, oh, it's coming in for this port. Oh, I got to change that port. Doesn't change it to the correct port, 3389, and send it to this specific machine. And so then I could direct it to a specific machine. Because using public addresses inside your network, and those aren't recognized from outside. No, using private addresses inside the network, but those aren't recognized from outside, that then I had to do something to be able to switch around on it. So with port numbers, and this is section 14.4.3 in your material. They go through and give you a whole list of them in the book, but they break them into 3 groups, and this is normal. So you need to be aware of these 3 groups, but you don't have to remember everything on it. So port numbers are split into registered ports, well-known ports, and then private ports is what the third one is. Now, well-known ports is from 0 to 1023. You should be able to just remember 1000. My experience has been if I remembered 1000 on that, I was good for test. They didn't get. They may have said 1023 is the answer, but there wasn't anything else close to 1023, so I knew which one it was. Those are ports that have been assigned to regularly used things by everybody out there, and those are used a lot. That's where you're going to have to know a few ports from that, which you're seeing right after that in your materials. Registered ports are port numbers that organizations for their software have gone out and paid to register that port number and said, we're the one that's going to use this port number. Okay. 3389, which is one I just gave you as an example, is actually a registered port, and Microsoft has registered it for remote desktop connection. There's a lot of others too, and so then organizations get to choose those. Now, if you're needing a port number for within your organization to use, what you're supposed to use is those private ports, which are from 49,152 through 65,535. Sorry. Registered ones were from 1,024 to 49,152 or 151. Sorry about that. Again, know the well-known ones fall from 0 to about 1,000. The registered fall from 1,000 to 49,000, and the private from 49,000 to 65,000. If you know those round numbers, you should be okay. That's been my experience on them. Now, that doesn't mean that they may not foul up and make it more difficult for you. But I don't think they will. So those are those. Now, in actuality, where you need to assign a port for some application you've developed, you don't have to use the numbers from 49,000 up. You can use the other numbers in there, but you just got to make sure no other application at the organizations that are using your application use that port number. So if you're going to distribute it out to lots of other companies, yeah, use a private port number or go and pay to register it with IANA. But if it's just for within your organization, look at what port numbers are usable and pick one of them. Your firewall, you will set to allow only those port numbers you want to allow traffic in on, because you don't want the hackers to come in on whatever. So now let's look at specific port numbers. There's two of them off the whole list that they give you that is a protocol that uses two port numbers. Only one of them do you need to worry about that on, but there is a second one that does. And as I go down this list real quickly for you, I'm going to tell you which ones you definitely need to remember, and then the others, it's not very often you'll ever see something referenced to them. 20 and 21 belong to FTP. Those two you need to know. And you need to be aware FTP uses two ports. So it uses port 20 to actually send the data. It uses port 21 to send control information. And remember, we just talked about control information in TCP, because FTP actually uses TCP and works just like to transfer a file, like we said. Secure Shell uses port 23, and Telnet uses, 22, and Telnet uses port 23. Now, Telnet shouldn't be used anymore. However, that one appears on test still, and that one's more likely to appear than Secure Shell. Telnet sends information across unencrypted. Secure Shell sends the information across encrypted. That's the difference between those, and that's when you're connecting into a terminal. And y'all have actually used Telnet in some of your exercises, I think, in here, or you will throughout the course. Although in real world, if it's not for a direct connection to a device, you want to use SSH. 25 is SMTP, which is Simple Mail Transfer Protocol. That is the protocol used to send email. Know that one. 25 will appear on test quite often. It used to confuse me with 23. 53 is DNS. That may or may not appear on stuff, although if you go and take Amazon AWS training, you'll find out their DNS on the AWS cloud uses Route 53, and DNS uses routers, and that is port 53. So you can remember what the name of the program is on AWS cloud because it fits right back with the protocol and the device. And it's a fun little name. Sort of, they based it off of sort of like Route 66, and where you hear things about that all the time, and so they called it Route 53. Then 67 and 68 are DHCP. I've not ever seen those two come up on a test, so I wouldn't worry about those two. Remember those two numbers as much, and that one of those is for the server and one's for the client, so those aren't quite as critical. Trivial file transfer protocol uses port 69. It's a Cisco test you're going to take, so I'd be aware on that one because Cisco uses TFTP. And that's where you're doing FTP using UDP. You're not getting the confirmation. You're using where you've got your machine connected directly to the router, and then you're going to transfer the config file from one to the other. Instead of doing FTP and all that traffic involved in on that, you know it got to the other machine because you're sitting there working on both machines physically right there with you. So you use TFTP, which uses UDP, and just throws it at the other machine. HTTP, definitely know. That's the one you probably might have noticed somewhere along the way. Sometimes your addresses you'll see up there on the URL bar have :80 on the end of them. That's using HTTP. Secure HTTP, which they've got it wrong in the book. It says Hypertext Transfer Protocol Secure. No, the spelled out name is actually Secure Hypertext Transfer Protocol, but the acronym has the S on the other end. So the S on the acronym comes at the end, but the words, the secure, comes at the beginning. That's when you're sending it across encrypted. That puts it in that locked lock up there in your browser. So, and there's a much more push to use HTTPS now instead of HTTP. But if it's just an informational site, HTTP works fine. So no 80 and 450 and 443. Sorry. 110 is POP, which is for receiving our email. And that's not used much anymore, but it's still there. That's when you download all of your email onto your machine and work with it there. That's the way it was done originally up through about 2000, 2003. I realize that's before a number of you in the class were born, okay? But that's still out there. So no 110 for that one. 143 is IMAP. That's what you actually use for email now, and that's where you work with the email on the server, and you don't pull it down to your local machine. It stays sitting on the server, and so that means I can work on my email here at the school on this computer. I go home, and I see exactly the same thing I saw at school as far as my email is concerned using IMAP. Now, before we did that, it used to be that was a problem because you downloaded it one and it's no longer sitting on the server, or you had to be very careful and leave it sitting up there, and it got real confusing. And then 161 is SNMP, which used to confuse me with SMTP, and that's our simple network management protocol. Uses 161. I wouldn't worry about that one quite as important. So the big ones I would worry about is 2021. 23, 25, 69, 80, 110, 143, and 443. Those others on the list I wouldn't worry about, and there's tons of others assigned out there. After all, there's 65,000 available port numbers. All right, that's port numbers on it. Any questions for me on all of that? The next chapter.
You said, do you remember 161 SNMP?
No.
Or no? No? Okay, cool. Thank you.
It could pop up on something, but that's not, if you're asking me which one should I really work on to remember,
Right.
I put that one secondary. Okay.
Thanks.
Because their list is nice, but you don't have to try to remember all of those.
Okay.
Okay. If you remember the ones I told you to remember, you should be safe and secure. And you can probably guess your way through if they did pop up a question on one of the others, because usually your choices are numbers that are other well-known port numbers. Okay.
Right.
The other one I would tell you to remember that's not on that list and it's not a well-known port number is 3389. I've seen that one pop up sometimes, which is remote desktop connection, which is used by a lot of people. Okay. So I would tell you to remember that one also. But beyond that, I wouldn't worry about any of the other registered ones. But that one pops up and stuff because y'all know how much remote desktop connection gets used in some way or another. Chapter 15 gets into the application TCP IP layer, or the session, presentation, and application OSI layers. Session layer, let me mention that one real quick to you. That establishes our conversation and maintains our conversation between the two devices. When I took this class, my instructor told us the way to remember the session layer is secretary. They both start with S. They're just like on a secretary for CEO. You tell the secretary to make a phone call for you. They establish a phone call with another secretary. Once they've got the call established, then they pass it off to their bosses, and then they actually have the phone call. The bosses did not make the phone call and establish it. And then at the end, they hand it back off to the secretaries to put stuff on calendar or whatever from what they talked about, and they concluded. But the CEOs don't really make phone calls, or the president of the United States, that Biden does not pick up the phone and just call somebody. He picks up the phone and tells the secretary to call whoever it is. If they were to call me, I'd pick up the phone and they'd tell me, this is the White House calling. Or at least that's what I've always been told, because I've actually never gotten a phone call from the White House. But and I've known people that did get calls from the White House, and that's what they told me. It was always, first thing you heard was, this is the White House calling. So the presentation layer, putting it going back upwards, gets it into the format that the application will actually be looking at the data. And coming down, it will take it from the format it was in, be it a PowerPoint presentation or a spreadsheet or whatever, and convert it into a format for the network. And that's all that occurs on presentation layer. Application layer, it takes our data from our application, our actual application, be it an email program, be it our browser, whatever, be it my GNTC, whatever, and puts it into and makes the connection between getting ready to put it on the network and the actual application. So the actual application is not on the application layer. This is where the network talks to the application. And that's all that's really occurring here on the application layer. It's a big part. Now, they show you the rest on what I've mentioned there. So they mention about peer-to-peer networks and client-server networks again, which I think we talked about back in like chapter 2 or 1. Peer-to-peer says all of our machines on our network are equals, and they're all responsible for everything that's on their machine. They can share it out with other machines, but they maintain their security. They keep up with what they've got on there. Client-server says there's a central machine that probably takes care of all of our security for our network, and also we'll have shared files sitting on it, etc., on that central machine, and the other machines are clients, and they just click in and use that server for managing all of that for them. So they talk on that a little bit. Peer-to-peer applications, there are a number of those out there. They mention about some of those. And they mentioned instant messaging is an example of a peer-to-peer. Some of y'all may have used peer-to-peer networks for music or videos where you go out and can get a copy of some music or a video where other people have shared it and you're actually clicking into their computer, not going to a server, but you're actually sharing it off of somebody's individual machine. That's what a peer-to-peer network is. Client server, so they mention on peer-to-peer net applications, BitTorrent is an example, and that's the only one of the 4 they list there that I really know anything about. I don't know anything about what Direct Connect, eDonkey, or FreeNet are, because I haven't used those, but I have seen and used on where you could share some music or videos on some of it. However, warning on anything with a peer-to-peer network, and I have shared stuff within a network inside the school that was peer-to-peer. But if you're sharing out there on the internet peer-to-peer, be warned. That's often a big issue out there of a lot of stuff on there gets infected. And that is a real good way to get your machine or network infected with some really bad viruses, ransomware, etc. So be careful with peer-to-peer. Peer-to-peer is where we were for a long time in the 80s and into the early 90s. Although client server has been around even back from way on back, and when it used to be a mainframe and clients attached to the mainframe, that was pure client server. So client server and peer-to-peer are both old ways of doing. They then talk about HTTP. I've already mentioned briefly to you on that about HTTP versus HTTPS, and that's what you're using for your web pages, and they're written in HTML. And so they just briefly mentioned that one to you, and about HTTP versus HTTPS. HTTPS is encrypting the information being sent from one machine to the other machine. HTTP sends it unencrypted. So that means somebody can hack in and pick up anything you send across HTTP. If you're doing send personal identifying information, PII, or credit card numbers or bank account numbers or whatever, make sure you're using HTTPS. The way to make sure on that is look up there on the URL, see does it start with HTTP or HTTPS, or 2, look and see there's a lock up there too. If the lock is locked, and I notice Collaborate is actually using HTTPS because it's got a locked lock up there, then it's sending it across encrypted. And so somebody can't easily steal the information going across the network. Then they mention email protocols. I actually mentioned that to you already just a little bit ago. POP3 is a way to download your messages and store them on your machine. You can still use it on a lot of the different email providers, although I do not think Gmail uses POP3 at all. I think Gmail doesn't have it in there, but a lot of the others do. SMTP is what you always use when you're sending the message. And actually, when you set up your email program, you'll see you have to set up about what your SMTP server is, and that's where is it, when you send a message, what machine does it send it to? And it uses port 25. Port 25 to do that. And then IMAP is what we're using as far as getting nowadays, because we leave it sitting on the server and we're just connecting to the server and working with it on the server. We're not downloading the messages to our machine and working with them that way. So they go through, talk about that briefly. And then they mention about DNS. We talked about that in a previous chapter, and that converts your domain name to your IP address, just as a reminder, and they show you that again, and that it tries on your machine to find out what the IP address is. If it doesn't know, it then sends a message to your DNS server. If it doesn't know, it sends it up a level for about 3 levels to the root DNS servers. That there's 7 of them, I believe, in the world. But normally you don't ever go up that high. So, and they mention about the hierarchy. which is just the extensions on the end of them. Used to be a limited number of those. Now there's an unlimited number of them, because if you want a special extension on the end of all of your web pages, you can actually go out and buy it. The Washington Post did. They bought PST. So if you go to their website, you're going to washington.p.ost. Notice it spells out Washington Post. But remember who owns the Washington Post? Bezos. So they got lots of money. And as lookup, they mentioned to you as being a way that you can look up your addresses on it and find out what the IP address is for a domain name. IPconfig will also give you some of that too. And then they mentioned about DHCP. Have we talked about DHCP in here before or not? I don't remember if we have or not. And I don't know if y'all can hear me or not now. I'm not seeing anything from y'all. I'm going to keep on going, assuming y'all can, but okay. DHCP is Dynamic Host Configuration Protocol. That is where we don't assign addresses to our individual machines, but we've got them, a clump of them, or what they call a pool of them, on a server. And when you turn your machine on, and this actually works on y'all's machines at home normally also, that they're not assigned to the specific machine. When you turn it on, it goes to your router and or your modem, whatever you want to call it. It's a router technically, as y'all know by now. And it requests an IP address for your machine. So the machine that's turned on sends a discover request. It broadcasts that. So every machine on your network sees this discover request. The DHCP server, and you could have more than one, will respond back with a DHCP offer, which is another type message. It's a broadcast also, because your machine has no address yet, and tells your machine, here's a number you can use. Now, if you've got more than one, it got several offers, and you choose one of them. Your machine will choose one. You really don't do anything with this. And so the DHCP client will send back to the one it wants and say, I request to use that number you just offered to me. Now, the other part on the offer is it went out as a broadcast, so everybody on your network saw that address being offered. Somebody is already using it. Something got goofed up on your network. Shouldn't be anybody using it, but if one machine is using it, it'll respond back and go, whoa, you can't do that. I already got that address. And so it catches that in the process there. But the client then sends back a unicast address back to the server and says, I request this, and sends a request message back and says, I request to use this number you told me I could use. And then the DHCP server will actually send back an acknowledgement to the client and say, okay, you got it. And so then at that point, they're set, and that machine has got a address to use. Now, what it's got is it's leased it. By default, they lease for 8 days. I don't know where they came up with the number 8 from. I would have set it as 7 if I was setting it up for a week, but they did 8 days. So it's good for a week. It's good for 8 days. After 4 days, it will actually, the client will send a request out about renewing the renewing it. So there'll be a renew request sent, and then the server will allow them to keep it or not. And then after 50% of the time again, if it's not been renewed, it does it again. So it's just like a regular lease out there, that if you go and lease an apartment, at some point during the year, actually it's not going to be a half a year, but usually more like if you leased it for 12 months, at 10 months, that you may well inquire about renewing the lease for another 12 months. So it leases the addresses out the same way. You can lease them out permanent. And in that case, it actually puts it at 0 days is how long the lease is for. 0 means permanent. Then they mentioned about FTP, File Transfer Protocol, which I've already mentioned to you in the previous chapter. That's to transfer your file from one machine to another machine. FTP works with TCP and works like we showed on windowing. TFTP is used mainly by Cisco, and that's Trivial File Transfer Protocol. And that one actually uses UDP and just sends it. Now, FTP is a confusing one for you because the program that uses FTP is actually File Transfer Program. So FTP uses FTP. File Transfer Program uses File Transfer Protocol. Okay. The server message block is another way to transfer your files. It's done some in the background on it, but I haven't specifically used it, but they always like to mention that in the books. That there is chapter 15, and it's 15 minutes after 12, so I guess we need to wrap it up. So this one's been a long one. However, I'll be glad to answer any questions for y'all at this point. So we will meet next Monday, and we'll cover 16 and 17. Most of 17 you've already covered. They're putting it all together about how to build a network here at the end of the book that you've already done. Okay? So y'all got it well covered there. So we'll cover 16 and 17 next week. Although I will have a session the following week also, but it won't count for any credit. But if anyone wants to join me in a session that day, they're welcome to. So I will be online on the 27th. But there is no engagement discussion grade that week. Okay? All right, so at this point, I think what we're going to end up doing, that I'm going to go ahead and end up doing, is that for your lab final, I'm going to go ahead and post out there the one that we used last year on it, where you're going to have to go ahead and put a network, some pieces of a network together for in Packet Tracer and do that. I would have liked to have done let y'all do the cabling on campus, but they're pretty tight on it around here about wanting to do stuff otherwise on it. Okay? Of not doing much of students on campus and everything, and some students aren't comfortable with it. So I'm going to skip over that at this point, but whenever we do get to have it open back up again, I will send out to y'all and to last year's classes also that y'all can set up a time with me if you would like to come up and learn how to do the 3-patch cables. I will be glad to work with y'all on that. Probably in the fall, I'm hoping, because I'm hoping things will be back to normal at that point. And if we're normal, then I'll do that. So your lab final, y'all will do, and I'll try to get it posted on out there today. And it'll be in assignments at the bottom of the page. Okay? So once we do get where it's fine for people to come and go on campus and to have lots of students floating around. We do have students on campus now, some, but until we get to where they're saying things are okay, I'll do otherwise. I have had both of my vaccines at this point. It's been 2 weeks since I had the second one, so I'm supposed to be fully covered by that now. All right, any other questions from anybody? But I'll be glad to do that at that point then. Or if fall gets here, summer gets here, summer into fall, and you'd like to come meet with me and do on it, write me and I may be able to go ahead and set up with different individuals, but I just won't make a mass offer until it's really free.
All right. Well, thank you.
Okay. Anyone else got any comments before we wrap this one up? And then y'all can go ahead and drop off, because I know I have taken more time than I told you I normally do. So y'all have a good day. I'll try to get these grades posted in there fairly quickly here in the afternoon. I've got another session in 45 minutes. All right, talk to y'all later.